Hello, everybody. We're recording another demo, another sprint demo for the team at Evernym that contributes to Indy and Sovrin. And I'm sharing my screen. You can see we've moved the agenda into the wiki. The biggest advantage to this is that you can search and find the videos related to the topics you're interested in. At this point, we've got quite a number of videos. I've only put the links to the most recent ones. They're all posted on YouTube and Evernym's YouTube channel. And I've got the links to the most recent ones here. But they're all in the YouTube channel, so the older ones you can go find there. And if you have a specific topic you're interested in, auth rules, freshness, view change, we've probably got a video about it at some point in the past year. The team's done a really good job at explaining the different projects they've worked on. So today we're going to talk about a chunk of design work we've taken care of. Let me go to the sprint board. So a chunk of design work, a chunk of cleanup, but the key effort we've put in is refactoring the way plugins happen in the ledger. And that's the goal, is to release that this month. There's some risk to that release. It requires a significant amount of testing. We might have to postpone things a little bit, but we're going to do our best to try and get that done this month or really early in July. We need to figure out what the Sovrin network has a very specific window when they can do upgrades, so we need to coordinate with them and other stakeholders before we can pick that release date. So that was the main focus on the Indy-Node side. On the Indy-SDK side, Sergey's been his one-man band. He's been focused on working while other people have been focused on Node, or we had some illness this sprint. People are feeling better though, and we've had members of the team on vacation. We've entered summer vacation season. So Sergey's been able to accomplish a chunk of stuff on his own, mostly architecture related. We've accepted a number of pull requests, and we've prepared a release for June as well. This release contains a contribution from the Government of Canada related to credential tagging, but it also contains some fixes for offline payments, being able to sign an offline transaction. But most of Sergey's time was spent working on architecture around credential exchange, payment decorators, and trying to think about what the difference between Aries and Indy should be on a technical level, and put a proposal together for that split. So you can expect to see that circulated at some point in the next couple of weeks as Sergey gets feedback from the team on that proposal. So that was the main effort there. We are still working on a potential token for the Sovrin network. There's no definite plan around that token yet, but it is in a state where people can start to play with it on the Sovrin test networks, on the builder net and on the staging net. And we hope that'll let people learn about it and get confidence and allow people to make decisions. The governance of the Sovrin network needs to decide how they want to proceed. And so that token is available for people to play so that we can make decisions around that. So you can see that at sovrin.org on the buildernet and staging net. There's instructions in the Sovrin forums at forum.sovrin.org. And so we made a lot of progress on integrating the token plugins to the ledger with the refactored handler. And there's the fix for the offline payments and some other fixes for libsov token that'll be useful. The next release of libsov token needs to correspond with the plugin refactor. We're calling this 1.0. We think it's ready for broad adoption once we get this refactor done. So we hope people play with it. But those releases will be done together, and that's the one where we have some risk at the end of the month. So we'll figure out how that goes. So that's the update on our progress as a team. So today we're going to talk about those architecture tasks. Once we've got the token refactor ready, the token plugins refactored, the next step is how do we make the ledger as solid as possible, as stable as possible. And we have long talked about view change being the Achilles heel of the ledger. It's not catastrophic in the majority of instances, vast majority of instances, but it could be a problem in some specific instances. So we want to clean that up. That's going to take a while. Alex is going to take us through that. And then we're going to talk about how that impacts Plenum. And then we've done some cleanup to the way nodes organized. We've made changes over the past few months, and we're able to get back and do some cleanup, remove some technical debt there. And then we'll go through the offline signatures. So with that, I will stop sharing my screen and let Alex share his screen.
Okay, thank you, Richard. Let me share my screen. Okay, so I'm going to talk about two architectural topics. They're closely related to each other. And as Richard said, we're going to start, actually we've already started implementation of the correct and proper vChange protocol based on PBFT protocol. And we have a design and POA for this approach based on the original paper of Liskov and Castro. And this POA exists here for a while, and I think it was presented on this demo last year. This sprint, we updated the POA, this design, according to the recent changes in the code, according to recent thinking, and for example, appearance of new major things such as audit ledger. And also I prepared a detailed plan, WBS, and the estimate. So I will very briefly go to the essence of this vChange approach. So unlike the currently implemented vChange approach, think of that when replicas realize that they need to do a vChange, they need to make sure that they are at the same state. And if something is ordered on valid nodes, that needs to be ordered eventually on all the nodes. And this protocol describes how they can achieve the same state. They use a checkpoint mechanism for these and a sequence of vChange arc messages propagating the pre-prepared and prepared certificates. And the new primary, the primary is a node, a replica responsible for suggesting the ordering of transactions. It sends a new view listing all the 3PC batches, all the transactions. They need to be ordered in order to have all the nodes at the same state. And all the nodes, they just reorder these 3PC batches, reorder them, even if they're already ordered. And after this, they can continue a normal flow of ordering already in the new view. You can look at this document in more details. It's in design folder vChange for more details because it may take quite a lot of time to describe it, all these items. As I said, there are a number of deviations from the original protocol. For example, in the current code base, we set the sequence number of pre-prepare with every new view. And also we have audit ledger, which persists the view number in the ledger, so that we need to take this into account. So this sprint we created a plan of attack how we can how we can take into account the current Plenum specific and apply it to the PBFT vChange approach. Also, you can see this plan here. It's mostly related to how we validate messages, pre-prepares and prepares and commits, and how we reapply, reorder messages from the previous view, so that the audit ledger is still consistent. Okay, the next thing closely related to this new vChange design, that in order to properly implement PBFT vChange and cover it by unit integration, simulation tests, we need to do a couple of architecture changes. As for simulation tests, this is very important because it's inefficient and hard to test the system only by integration system or load testing, and we need to have a good simulation and property-based tests basis here, so that we know that under different conditions and different sets of input parameters, we still behave properly and can test the protocol, that protocol implemented and works correctly.
And
yeah.
Just to clarify, Plenum is the actual distributed ledger implementation used by Indy-Node, and the view change is backwards incompatible, so we need to rev the version. But this is a separate effort, a much smaller effort than what we've been calling Ledger 2.0, which is a much bigger, let's rethink Indy-Node in general. So this is distinct. It helps, but it isn't the whole thing.
Yeah, this is more low level.
Yeah.
So we're not going to, change the global interfaces or the protocol for now, but this is more low level how architecturally it's going to be done. And the goal here is to avoid tightly coupled monoliths and have loosely coupled microservices, so that we can efficiently test them and really improve communication flow, maintainability, support, and eventual debug and testing. So I'm going to describe it in more details a bit later, but also we came with the implementation plan. We came with the implementation plan. You can see it also in this ticket. How we are going to achieve our goal to have a workable and properly tested PBFT change, which fits appropriate architecture for this. So we are going to do it incrementally in small pieces and start working on the simulation test from the very beginning to have a confidence. And the goal here is to have something releasable, so that every small change is going to be immediately integrated into the main code base, so that all the tests pass and so on. For example, we are going to define interfaces we need. We call this new interfaces Plenum 2.0. And then we're going to take pieces from monolith replica and put it into this, implement these interfaces and integrate them into existing code base. So this step-by-step improvements, integration, together with the new implementation of view change protocol and simulation test for this, should lead us to our final goal. And as you can see, it should take about roughly 7 sprints. So the final work is going to be done by end of September, something like this. Okay, so as for the Plenum 2.0 architecture and our new approach that we propose. So this includes 2 main steps. And in the scope of PBFT change, we are going to do only the first step for now. But in the architecture, we account for possibility of doing both the steps. So the first step here is to split tightly coupled monoliths into a number of microservices, where vChanger is one of them. So this will be done here according to this estimate. The next step is to move some of these microservices into separate processes, because that's actually what is needed for a proper RBFT implementation. Each replica needs to be run in a separate process. It's not in the current scope for view change work, but in this architecture we account for this possibility, so that eventually it will be easily possible to do this. And again, after PBFT change is done, and if you go into Node Ledger 2.0 phase, we may decide if we need to do this or not. Let's go to the description of this Plenum 2.0 architecture. And again, these docs can be found in the design folder. There is a general description of this new architecture and a number of diagrams, class diagrams, object diagrams. So the general principles that we are going to follow, that instead of monoliths, we are going to have a number of microservices with a clear separation of concerns and possibility for efficient unit integration and simulation testing. Eventually, we would like Plenum to become a multi-process application where each process may consist of multiple services. So as a natural example of these processes is replica. Every replica needs to do the same work and be run in a separate process. Services do not communicate with each other directly, and they do this only via buses that use observer pattern internally. And we are going to have three types of buses. Internal event bus, this is for service-to-service communication within one process on a node. External event bus, this is between node-to-node communication and client-to-node communication. In other words, external event bus is for sending messages from one node to another node via some network interface, where internal event bus is just for this actors or microservices communication. And this is not in the scope for PBFT change, but later on we may implement inter-process event bus for service-to-service communication between multiple processes. All services communicate via messages. Here again, we have internal messages and we have external messages, which go to the network. Okay, as for the main services, here's a list of all the services, and it's mentioned in one process they may be attached to. This is a read request service for processing of, well, maybe I can show this on these diagrams. This is a class diagram. And you can see we have a consensus part here with a replica and with an orderer service, checkpointer service, view changer service, sharing this a common state, consensus state, a 3PC state. We have write requests, read requests, managers, and this is actually what is already done in the scope of pluggable request handlers. So this left part is almost done this sprint. We have catch-up, set of catch-up services. This is also already done. This is already done. This already works. And we are going to have a network and this external and internal buses. So what is in the scope of PBFT change is to work on this central part, is to split order service, checkpointer service, and view changer service. On this picture, we can see how eventually it could look like from the process point of view. So we're going to have the following processes: a separate process for processing of read request. It doesn't require anything except read-only access to the ledger. We're going to have a separate process for servicing catch-up requests from other nodes and clients. It also doesn't require anything except read-only access to the ledger. We're going to have a node process for coordination between replicas because RBFT has multiple replicas running in parallel. And we're going to have a master replica process. And in this process, we have a number of services communicating via internal bus and external bus for communication to other nodes. As for detailed workflow for communication, you can see it on this diagram. You can see these processes here internally, and you can see that services within one process are communicated via internal bus, not directly, but via internal bus. Then communication between nodes is done via external bus and via external separate network interfaces, for example. And we can have separate ones for every replica like this. And of course, we have read requests, which go to the corresponding endpoints, to the corresponding services, and write requests and catch-up requests. So again, internal bus is for service-to-service communication within one process. External bus is for node-to-node communication, like this. You can see node 1 and node 2. And inter-process communication is for communication between multiple processes. This is not for the short term, but for a long term, it may make sense. Okay, so we can investigate these diagrams in more details. As I said, they're all in design folder. And we already started this work. Some drafts of some interfaces already prepared. And next sprints, this was really very brief discussion because of lack of time, but next sprints, I hope that we are going to, we may describe in more details how implementation goes and how it matches to this approach and these diagrams. That's all.
Thank you. And now Artem will take us through some of the interface improvements we made. Interface cleanup.
Yeah, thanks, Richard. Welcome, everybody. Let me share my screen. Well, I'm gonna tell you about two minor fixes that we've done on the Node side. The first one is removal of anyone can write feature. This one was introduced back in 2018 when we had no. For now, we have advanced authentication and authentication system, which allows us to set any permission for any transaction which we want and make it very flexible and comfortable to use. But back in 2018, we had no such opportunity, and we had to implement anyone can write feature, which was just predefined set of rules, telling in short, which allows just every client to send any transaction, change any roles on the ledger, and do which allows this feature was useful for playing with system or something like that. After that, we implemented our detailed, improved authentication system, and that feature anyone can write became redundant. So that this is what the question of time when we took a decision to remove it. It was pretty easy. Just some old code which was integrated together with our new advanced solution. So it was removed from code successfully, and we have only our cool advanced authentication system. That's for removal.
And just to clarify, the end goal of the Sovrin network is for it to be a permissionless network where anybody can submit transactions to the ledger. And of course, there's some cost there. There's a potential of abuse. And so we didn't want to turn on anyone can write unless there's also a payment mechanism like a token that corresponds with that. Now that we have our auth rules, we can do that in a more fine-grained way. So this was able to go away. And you can see more about those auth rules by looking in the history of these demos, the agenda that's on the wiki or on the YouTube channel. We have lots of topics about how to use those auth rules.
Yeah, that's right. Well, that's for removal. And another one small fix in our code base is renaming and trust anchor to endorser. The trust anchor is a role in a Sovrin ecosystem that used to be used for delegating the right to write transactions to the ledger. In short, if you do not want to interact with the ledger directly, you can make an agreement with some trust anchor and send transactions to him so he could delegate it to the ledger. That was in the past. For now, trust anchor is perform a bit different role. For now, it is uses for referring to the organization sponsoring a government's framework around credentials that are trusted by a specific industry. which was written in a description of this ticket. For purpose of replacing trust anchor role, we introduced Endorser role, which is now stands for the same functionality that stayed for trust anchor. In short, that the fix itself was pretty easy, was done almost by using full text search. A bit of more interesting changes was in acceptance testing, when we needed just to add more zeros to satisfy 32 bits condition for seed. Well, so this fix was also pretty easy. For the ones who wanna investigate these changes, understand these changes in more detail, we can offer you to visit a Sovrin glossary, which is mentioned here in comments of this ticket. Richard, I think we can link this ticket in the description of video.
Oh yeah, good idea, thanks.
Yeah, well, and here you can read a more detailed description of these roles and what are they stands for. That's all for me. Thank you for attention.
Thank you. And then the last item is Vladimir is going to take us through offline transactions. There have been a lot of requests for how do I control my wallets, my secret store to make sure that it can't be hacked, especially when we're evaluating usage scenarios like payments with the potential sovereign token. And so one way we want to do that is be able to say this is done completely offline. You take your transaction to that offline system, you sign it, you bring it back. It was supposed to work, but we found a bug. So Vladimir is going to take us through that.
Hello, let me share my screen. Can you see my screen?
Yep.
Okay, so now we have two CLIs, and in the first one, I just create one offline wallet that will not be connected to any pool. I'm creating several payment addresses for minting and payment transactions. And now in this offline wallet, I can make an offline assignment of the payment transactions that have inputs and outputs, but this transaction will not be sent to any pool since we have no active pool connection. So I use send false marker, and you can see that transaction has been created. So I have some JSON value, and now I can save this transaction into file and send it to somewhere, to anyone to send this transaction to the pool from the other wallet, other CLI, and so on. So the transactions has been successfully saved, and now we can send it from another CLI client and another wallet, online wallet that has a pool connection. You can see that I just not only create the wallet, but now I I'm connecting to my Docker pool. And now, since I have a pool connection, I can perform a get payment sources request to check that our address has some tokens on it. And now I can load transaction from file from the first CLI and push it to the context of the CLI. And now I can just send it by this command, ledger custom context. So I just push the transaction from the file to the CLI directly. And now you can see that I've got response from the pool on my online client with op reply. So transaction from offline client that was already signed was successfully sent to the pool from our online client without any signatures from his side. So that's all.
Thank you for demonstrating that. I'm going to have to go through that. I'm going to review this recording and go through it in some detail to make sure we need to adapt that to our internal wallet control mechanisms. Thank you for that. We have a couple attendees in the call. Any questions from anybody? So we're out of time, but if you have a question, reach out at chat.hyperledger.org. We hang out in the Pound Indy channel, Indy-SDK channel as well, and we'll start hanging out in the Pound Aries channels too. In late 2018, we set out a certain roadmap of ledger improvements and working on the sovereign payments, and we've largely completed that. A bit of celebration is in order, and now we're moving away from that chunk of work. We need to do PBFT change, and I guess we're gonna celebrate by doing a bunch of bug fixing that got postponed. And at the end of the year, we'll be able to start tackling some new features that have long been requested by our customers. So we're excited to be moving into a different phase of development. So it's fun to see how reliably this team has been able to create a plan and execute on it and adapt to everything that's come up. So thank you for everybody's professionalism, and we hope people enjoy their summer vacations as we're going to move a little bit slower for the next couple of months and have some team shuffling as well. People are going to move to some new assignments. So we appreciate everybody who's been part of this team for the past year and has got a lot of good work done. So thank you. With that, let us know if you have any questions.